All right, ladies and gentlemen, I'm going to hustle through this. The bell's going to ring pretty quick, so I'm going to talk fast, but hopefully it'll be better than nothing because after school I have conferences. So when you have a triangle and you need to give the trig functions, you need all three sides because SOHCAHTOA, right? I'm going to need the opposite hypotenuse, adjacent hypotenuse, opposite, and adjacent. This is going to be opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. But in this picture, if this is the angle, straight across from that makes 8 my opposite, and straight across from the 90 makes this unknown side my hypotenuse, which makes the 15 the adjacent. So I don't know the hypotenuse. The way to find a third side is always Pythagorean theorem. The two that get added together are the ones that make the 90. So 8 squared plus 15 squared is going to be my hypotenuse squared, but that's a side that I don't know. So if I do 8 squared and 15 squared added together, I get 289. And then I check to see if that's a perfect square, and in this case it is. So that last side becomes a 17. It's not always a perfect square, but in this case it was. So 17, 8, and 15 are my three numbers. For sine, I need the opposite, which is 8, over hypotenuse, which is 17. Cosine adjacent is 15, hypotenuse is 17. I'm just looking at the numbers on my triangle. Opposite over adjacent for tangent, opposite is 8, adjacent is 15. Okay, here they're giving me the information in a little different way. Cosine is always adjacent over hypotenuse. So if I drew a triangle and I had my angle here, this is going to be opposite, adjacent, hypotenuse. I know the hypotenuse is 2 because they said so, and I know the adjacent side is 1. I do not know this side. So since these two make the make the right angle, I'll have x squared plus 1 squared equals the hypotenuse squared. So in this problem, I'm not going to get a nice pretty number that is a perfect square because I get 3. So the square root of 3, I just leave as a square root of 3. Now I know all three sides, and I'll be able to put them together over here to do my sine, cosine, and tangent, just like up above. Sine is opposite over hypotenuse. So looking at my picture, that's root 3 over 2. Cosine was given in the problem. Tangent's opposite over adjacent. So in my picture, opposite is root 3, adjacent is 1. You could certainly just write it like that. I don't care either way. All right, here the concept is finding the reference angle, which is the one that's always positive. It's always less than 90. It's telling you how far you are away from the x-axis. But first we have to draw it. This is degrees. You always, always, always start here. When you're drawing an angle, positive is up, negative is heading down. This is 90 degrees, this is 180, and I'm just trying to create a dial so I know where to stop. So I'm going to go ahead and pass 90, but I am not going to pass 180 because 130 is not greater than 180. So that's my angle. And then the reference angle is saying, are you closer to the left or right end of your x-axis? And obviously you're closer to this. So that makes this little corner your reference angle. And you just look and say, okay, how far away are you? And the answer is 50 because there's 50 degrees between 130 and 180. So you are 50 away from the x-axis. This one's tricky because it's radians, so I keep saying you still need to create a dial to help you. When you do that, the left side always has the same number on the top and bottom, and the right side always has double on the top so that it can be 2 pi. This is a negative, so you're actually going to be heading this direction. So think about it. What is halfway to 3? 1.5. So 1.5 pi over 3 is at the bottom. The over 3 part stays the same. And then that's as far as I need because I'm only going to go to 2. So I know to go past 1.5, but do not go past 3. And I'm going this direction, so I guess all of these are negative. And so this is my negative 2 pi thirds. The negative just tells you which direction you came from, the starting point. And so then that's the picture because I know that negative 2 isn't going to pass negative 3, so I have to stop before I get there. But now the question is, which end am I closer to? Well, I'm obviously closer to this end of the x-axis than over at the 6 pi side. So that means this is my fastest way there. Well, if you are at 2 pi and you're trying to get to 3 pi, you are only 1 pi away. So that is my reference angle for that one. One positive and one negative coterminal. Okay, coterminal means that you're adding a trip around the circle or subtracting it. So in degrees, that's 360. Or in radians, you're adding and subtracting 2 pi. And 2 pi is always going to mean whatever's on the bottom, double the top. If you got a 4 on the bottom, double the top. Those all mean 2 pi or 1 trip around the circle, but that way you have a number on the bottom that's a common denominator so you can add. Not a problem here. I literally am going to take negative 134 and I'm going to add 360 here. And that's going to land me at 226. So those are in the same spot. They just are more trips around the circle. Here I need another negative option, so I'm taking away a trip around the circle from my original. And I'm ending up with negative 494. Here I have to do the same thing. I have to add and subtract 2 pi. Well, what's 2 pi going to look like if you have a 9 on the bottom? The top always has to be 2 times that, because 18 over 9 will reduce to be 2 pi. So I'm going to basically be adding that trip around the circle, the 18 pi ninths. I'm going to add it to the 11 pi ninths and get 29 pi ninths. And to get a negative, I'm going to take my original angle and subtract that trip around the circle. 11 minus 18 would leave me with negative 7 pi ninths. That is coterminal, add and subtract trips around. If you don't remember those terms, you got to go into your note packet and make sure you've got them because they're in there. Converting, you're going to be using the conversion factor that pi radians is equal to 180 degrees. And you use it differently depending on what you're doing. If you're given degrees, you're going to set it up next door to this conversion where the degrees are on the bottom so that the degree will cancel. This pi is going to end up in your answer. You're just trying to figure out what fraction of pi is 160 over 180. And you got to figure out either with your brain or your calculator how to reduce that. So I'm going to go and reduce 160 over 180 on my calculator or with my brain. And I'm going to get 8 ninths. So 8 ninths is the fraction of pi that is equivalent to 160 degrees. This is actually easier because pi is 180. So if pi is 180 degrees, then where there was a pi, I can write 180 degrees. And now I'm just going to do my calculator, 5 times 180, divide my answer by 9, and it tells me that that would be 100 degrees. So that's about converting. Find that in your notes packet and make sure that what you have makes sense. Okay, these are the ones where you draw yourself a triangle based on what they tell you. So this point is negative 10, negative 24. I don't really care how accurate it is, but I know that's negative x, that's negative y, and then you always connect back to the origin. Your angle's always there, your 90's always there. Okay, so I know 2 out of the 3 sides. I know from here, this is opposite, adjacent, because remember opposite is always the y, adjacent's always the x, and then this is my hypotenuse. So I know that 10 squared plus 24 squared will equal the hypotenuse squared. And I am not messing around with the negatives because all they're doing is showing direction. But if I try to square them, it'll make it all messy. So I just take the numbers. So this is 676. And then I'm going to check and see if that is a perfect square. I'm just doing Pythagorean theorem. And it is. So this side's 26. Your hypotenuse is always positive. So I have a negative 10 here, a negative 24 here, and a positive 26 there. So it wants the sine. This is like what we do all the time. Sine is opposite over hypotenuse. Looking at my triangle, opposite is negative 24, hypotenuse 26. I should reduce my fraction, so negative 12/13 is the better answer. Cosine is adjacent over hypotenuse. Looking at my picture, that's negative 10, hypotenuse is 26. Those both divide by 2, so negative 5/13 is my better answer. Tangent, opposite over adjacent. So the opposite is negative 24, the adjacent's negative 10. Here the negatives cancel and I end up with positive 12 over 5. So these are the reduced, simplified, and therefore right answers. Next problem is exactly the same. I just start off in a different direction. I go 12 in the positive direction, and then I go down 5. But I created that 90. I connect back to the origin just like in the last problem. This is my angle. This is my hypotenuse. This is a cross, so the y is my opposite. The x is next door to, so that is my adjacent. And just like before, I take my x squared and my y squared to get my hypotenuse squared, totally ignoring the negatives because it's just directional. So 5 squared plus 12 squared is going to give me 169 equals h squared Just Pythagorean theorem. I'm using that so many times that you should find yourself using it so many times. So that tells me that hypotenuse is 13. My three numbers are going to be -5, +12, and 13. I labeled the triangle already with opposite, adjacent, and hypotenuse, so this should be easier. Opposite over hypotenuse is going to be -5 over 13, doesn't reduce. Cosine, adjacent over hypotenuse. So 12 over 13, doesn't reduce. Tangent is opposite over opposite over adjacent. So the negative is with the 5 and it's over 12. That's it. Okay, so these two you do not have to worry about. They're the ones that have a lot of extra math. But in these three scenarios, that's when you have to remember that if you're trying to find an angle, you're going to be finding one off your calculator, but to find the second option for sine inverse, you take 180 minus the first option. If you're doing a cosine inverse problem, the second option is 360 minus the first. And if you're doing a tan inverse problem, your second answer is 180 plus the first. So this is a sine problem right here. I'm going to go ahead and do it on my calculator, sine inverse of 0.43. When I do second sine 0.43, my first option is 25 degrees if I round it, but that's not between 90 and 180. So I go for my second option by using the rule from down here, and I do 180 minus 25. So 180 minus 25 lands me at another option of 155, which does fall between 90 and 180, so that's the one I need. Okay. So I guess this one actually will probably work. So let's go ahead. This is tan inverse. So I do tangent inverse of -0.27. Oh, excuse me, -2.7. So inverse tangent -2.7. And my first option is -70 when I round it off. But that's not actually what I need. So I try my second option, which takes 180 and adds it to that answer. So I'm going to do 180 plus the -70 that I got, and it puts me at 110, which is actually in the range that they gave me. And then this one's a cosine. I don't care if it's a fraction. I'm still going to do cosine inverse -5 over 11. They told me the cosine, so I'm just going to ask the calculator what angle has that cosine. So I'm doing second cosine -5 divided by 11. And I'm getting for my first option 117, which is not in between 180. So I go to my rules down below and I find out that for cosine, I'm going to do 360 minus that answer. And when I do 360 minus that answer, I get 243, which is in that category. Now the only thing, and I talked about this on the board, but I didn't, there's not one on the review. If you're going to have a triangle where it asks you for the angle, and then it might give you like this is 5 and this is 7. And so what you're going to do to find the angle is you always have to use inverse. So you have to be like, okay, you told me 5, that's opposite. You told me 7, that's adjacent. So opposite and adjacent means I need to use tangent. I'm finding an angle, so I'm going to need tangent inverse. So tan inverse of opposite over adjacent. So I go second, tan 5 over 7, and I find out that that's a 35.5 degrees. So I'd give you credit for 35 or 36 or whatever. And then on these, your answer is always exactly what it says on your calculator. You don't have to find a second option. So hopefully that helps you, and I'll get this posted as soon as possible so that you can be super awesome on the quiz on Friday. Bye, guys.